I'm Shalaka Deshpande and welcome to my YouTube channel. Today's topic is timer units in 8051 microcontroller. Now the first question is why timer is required in 8051 microcontroller. Now take the example of our real life. We judge whether the quality of a product is good, better or best according to the work performed by object in the amount of time. If an object performs best work in a small amount of time, we make it as a very good product. Similarly, our performances in exams is judged by how much we can score in the less amount of time. So in a real life, we use a particular time reference to judge the quality of a person, object or anything. So similarly, as we require a time reference in real life, a time reference is also required in a microcontroller 8051. Okay, so the timer is used to generate the delay in the microcontroller process. Okay, suppose a microcontroller is performing any task and I want to generate a delay in performing that task, then timer unit are used to generate a delay. Okay, they are used to generate a time reference, means how much time is required by the processor to complete a particular task. Okay, so that is timer units use. Okay, now this 8051 microcontroller, it is having two timers, timer 0 and timer 1. Each timer is of a 16-bit, means total 16-bit of data can be stored inside these timers. Okay, now this timer 0 and timer 1, these two timer, it can act as a timer unit and it can act as a counter unit. Okay, then it is functioning as a timer, it increments every one machine cycle. Okay, when it is functioning as a timer, for every machine cycle it is incremented by 1. Now what is machine cycle, what are T states, what are the clock pulses? I have explained this in the execution speed of 8051 microcontroller by Shalaka Deshpande. Please refer that lecture before referring to this lecture. Okay, if you don't have the concepts clear. Now next is if the timer 0 or timer 1 act as a counter. Now on 8051 microcontroller chip there is a one pin called as a timer counter pin. Okay, and when 1 to 0 transition is detected on that pin, and when the timer 0 timer 1 is working as a counter mode, and when 1 to 0 transition is detected on timer counter pin, then counter is incremented by 1. So in this way it can work as a timer and it can work as a counter. Okay, only the instance when it is incrementing by 1 is different. Okay, now there is one more concept which is related with this timer 0 timer 1, that is a overflow. Now we all know that these timer 0 and timer 1 we can store 16-bit of data. Now assume that the 16-bit data 0000H is stored. Suppose this is the 16-bit data 0000H. This 000H is stored in a timer 0 or timer 1. Now it will be incremented by 1. After incrementing by 1 it becomes 0001H. Okay, now again incremented by 1 it becomes 0002H. So it gets incremented by 1. Okay, and finally it reaches the value FFFFH. This is the last limit. Okay, and when it reaches this FFFH, again it is incremented by 1. Okay, after reaching the last limit, when again it is incremented by 1, it rollovers from FFFH to 00H, means again it becomes, when it is incremented by 1, again it becomes the starting value, that is 0000H. Now this process of a rollover from FFFH to 0000H is called as an overflow. And when this overflow occurs in the timer 0 or timer 1, the overflow flag inside the timer counter control register is set to 1. Now there are two registers which are associated with the timer, and these two registers are of 8-bit, which I have drawn on the board. Okay, see, these are the two registers which are associated with the timer 0, timer 1, and these registers are of 8 bits, and these two registers are the special function registers. Okay, It contains the timer run control bit and interrupt bits of the timer 0 and timer 1, and we are going to discuss the each bit in detail. First we will see the timer counter control register, then we are going to see the timer counter mode control mode register. Okay, fine. So in this way we are going to study the both registers. Okay, so first we will see the TCON register. You can see the bit 7 of the TCON register is TF1. Now what is this TF1? This TF1 is a overflow flag. When the overflow occurs, we have already discussed what is overflow. When the overflow occurs, this TF1 bit is set to 1, and it is 1 till the interrupt related with the timer 1 is executed, and when the interrupt related with the timer 1 starts executing, this bit TF1 is set to 0. It is for timer counter 1. Alright. Now next bit is TR1. Timer 1 run control bit, means it checks whether the timer should be running or timer should not be working, that is it should be stopped. When TR1 is 1, it means that timer is running, it is working. When TR1 is 0, means timer is stopped, it is not working. So it decides whether timer is running or whether it is stopped. Now next bit is your TF0. TF0 is similar to TF1, that is the overflow for the timer 0. Means when the overflow occurs in the timer 0, this TF0 is set to 1. Okay, and when the interrupt related with the timer 0 is executed, this TF0 again becomes 0, means it is cleared. Okay, clear? Now we have a TR0, means timer 0 run control bit. When this TR0 is 1, timer 0 is running, and when the TR0 is 0, it stops running, it is not working. Okay, now we have IE1, external interrupt 1, edge detect. Okay, when the edge of the interrupt is detected, when the clock pulse on the timer counter pin is given and its edge is detected, edge of that interrupt is detected, this IE1 bit is 1. Okay, and when the interrupt related with that corresponding timer counter is executed, this IE1 becomes 0. Here we have timer 1. Alright. Now IT1. Okay, IT1 is external interrupt 1 type control. Means when it is 1, it configures the timer 1 interrupt as a edge triggered. Means the timer 1 interrupt which is occurring, that timer 1 interrupt occurs when the edges are detected. Now what is edges and what are levels, I will explain you. Can you see this square waveform? You can see these vertical lines. You can see these vertical lines. These vertical lines, these are edges, and these horizontal lines which make it the square waveform, these are the levels. Alright. So when this IT1, external interrupt 1 type control, when this bit is 1, it configures the timer 1 interrupt as edge triggered. Means when edge of the interrupt, when the edge of the square pulse is detected, okay, then it interrupt starts executing. Okay, means it is edge triggered interrupt. Alright. Now when this IT1 is 0, means it configures the interrupt 1 as a level trigger. Means when levels of the square waveform are detected, interrupt starts executing. So level triggered interrupt. Alright. Now next is IE0 and IT0. Now this IE0 and IT0 are same as IE1 and IT1, which I have explained you earlier. IE1 and IT1 are for timer 1 and IE0 and IT0 are for timer 0. I hope this much is clear to you by now. Okay, now next register is a T mode register, timer counter mode control register. Alright. Now first is gate, first bit. Now it is having total 8 bits. Out of these 8 bits, the 7th bit, which is gate, we will discuss that. What is this gating control? When this gating control is 1, the timer 0 or timer 1 is enabled, but there is one condition, that int 0 or int 1 pin has to be 1. It has to be logical 1. Okay, and second condition, that the timer run control bit corresponding to that timer or timer has to be enabled, means it has to be 1. Okay, so TR has to be 1 and INT 0 or INT 1 has to be logic 1. If these two conditions are satisfied, then the timer 0 or counter 0 or timer 1 counter 1 are enabled. Okay, if these two conditions are satisfied, if a gate is 1 and when this gating control, when this bit gating control, when this is a 0, then only one condition has to be satisfied, that is the TR bit has to be 1. When the timer run bit, when the timer control run bit is 1, then your timer 0 or timer 1 is enabled. Okay, fine. So these are the differences between 1 and 0 of gate. Now next bit is C#T. It decides whether the that timer is working as a timer or it is functioning as a counter. Means what? If C#T is 1, means that timer act as a counter, and if this C#T is 0, means that timer is functioning as a timer. So to decide whether to act as a counter or whether to function as a timer is decided by C#T bit. Now next point is, these timer 0 and timer 1 register, they work in the 4 modes, that is mode 0, mode 1, mode 2 and mode 3. Alright, so mode select bits we will require. So these mode select bits are M1 and M0. M1 and M0 are used to select the modes of timer 0 or timer 1, means in which mode it is operating. It operates in 4 modes. So let's see those 4 modes. When M1 is 0 and M0 is 0, timer 0 or timer 1 operates in the mode 0. When M1 is 0 and M0 is 1, it operates in mode 1. When M1 is 1 and M0 is 0, it operates in mode 2. And when both are 1, it operates in mode 3. So basically M1 and M0 are mode select bits. It selects the mode of timer, in which mode we want to operate the timer. Alright, according to its application. Now these bits, you can see the first bits from the bit 7 to bit 4, these are for timer 1, and from bit 3 to bit 0, these are for timer 0. So total 8 bits of TMOD register. So in this way we have studied what are the timers, why they are required, and what are the registers associated with the timers and their working. Okay, we have seen the bits which are present inside those registers. We have seen those bits in detail. Okay, so this was about the TCON register and TMOD register. I hope you like the video. If you have any doubt, you can ask me in the comment section below. Please like, share and subscribe my channel. Thank you for watching. Bye bye.